Just ahead, our year in review. Our 2020 podcasting journey started at hypersonic speeds. Along with the world, we rounded the corner into a global pandemic. And a bright spot to end the year, discussing award-winning SWRI technologies. Our best listen and learn moments of unpredictable 2020 on this episode of Technology Today. We live with technology, science, engineering, and the results of innovative research every day. Now, let's understand it better. You're listening to the Technology Today podcast, presented by Southwest Research Institute. Hello and welcome to this special episode of Technology Today. I'm Lisa Benya. 2020 has been an incredibly challenging year. We have all felt the impact of the global COVID-19 pandemic. To our listeners hit especially hard by the circumstances this year, our hearts go out to you and our thoughts are with you. This year, the pandemic shifted how we podcast. On the mic, we tackled COVID research and mask materials testing. Off the mic, as we transitioned to working from home, we found new ways to record our conversations, going from our studio to the phone and finally to webcasting. No matter our techniques behind the scenes, I hope you've enjoyed listening this year and that you have found an opportunity to learn something new. SWRI scientists, engineers, and researchers stayed on track this year, continuing to make world-changing discoveries. So let's get started with our top listen and learn moments of 2020. Back in January, we spoke to Dr. Nicholas Musick, an SWRI engineer, and Dr. James Walker, director of SWRI's Engineering Dynamics Department. They study hypersonic speeds, launching projectiles at thousands of miles per hour. They discussed where today's hypersonic research could take us tomorrow.
Another new area, which is a little further out, as Nick mentioned, but I think is super exciting, is this notion of actual hypersonic airliners. Of course, we don't have supersonic airliners right now, but we're still hoping for the hypersonic airliners, and that leads to some new technology as far as engines go, which we really haven't touched on. But the U.S. had a program called the National Aerospace Plan, which was in the late 80s, early 90s. A lot of research on can we actually do a single stage to orbit. That was out of reach, but a number of technologies were developed, but just need further development to try to have these kind of flight bodies. It's typically called a scramjet, supersonic burning aircraft engine, jet engine. And we need to have more breakthroughs in this area in order to have that hypersonic commercial airliner. But right now, we also need the supersonic ones. And, NASA has a number of programs with a number of the airlines for maybe some small private supersonic business type jets. But there's also this hope of getting the hypersonic ones where you really can do overseas travel in just a couple hours.
That would be amazing. Who wouldn't want to do that, right? But how far off are we talking when you say it's well off into the future? Do you have a projection as to?
Well, it really depends, right? And right now, as was mentioned, we're kind of in a fifth or sixth wave of hypersonics. It started back when we talked about X-15 and Gemini and Apollo. We're now kind of at another wave where Department of Defense is investing in it. And right now, their short term is the boost glide that we talked about, where you do hypersonic glides. But they're also investing in missiles that will have air-breathing engines, which are the scramjet technologies, what we assume is the technology that will win out. So those we could see towards the end of the decade. You talked about we're new 2020s, right? This decade will probably happen missiles that have that technology. Once that's in use and tested out and being lots more research happening on it, it's very possible that the end of the 2030s could see something human-manned.
When you're on your first hypersonic international flight, think of our engineers and their fascinating research. From speed to a sophisticated antenna technology, taking signals intelligence to a new level. In February, SWRI electrical engineer Brandon Nance introduced us to the AF369 direction finding antenna.
We think about antennas helping us watch TV, for instance, but what are some of the practical uses for antennas in general?
Antennas make it possible for us to communicate electronically without wires, obviously. So, all of the communication signals, for emergency use, police dispatch, cell phones, for God's sake, Wi-Fi, all of the stuff we depend on and just kind of take for granted these days, all made possible by antennas.
So let's talk about this antenna in particular. And it is bolstering signal intelligence. How does it do that?
Yeah, so it allows not only provides enough sensitivity to pick up signals in the first place, so that signals across that huge span of bandwidth can be monitored, so that further processing and information can be pulled out later. Like we said, it provides direction finding capability, and estimates direction of arrival of signals. So not just knowing what they're saying, but maybe where they are.
So how is the AF369 antenna used in the real world, some real world applications?
Yeah, so what our customers do with these specifically is kind of up to them, and we don't get in the middle of it, to be sure, but we envision when we created this thing that there might be a range of scenarios. Well, so it's conceivable, you might want to listen to signals coming from out over the water, to protect a port of entry or something like that. You might, for situational awareness, law enforcement activities, you might want to know kind of what people are saying out there in case they're trying to do something against the law or something that might harm the United States. If they transmit anything over the air that might give that away, these antennas can be used to help pick that up and give early warning to people for force protection, law enforcement reasons, and those kinds of things.
Definitely an antenna with powerful capabilities. Moving into March, SWRI Institute scientist Michael Miller discussed the Lotus Flow super hydrophobic coating, a breakthrough for the oil and gas industry and ultimately for consumers like us.
So what does better flow in the pipes mean for the industry?
It means a lot because any plugs that develop in a deep offshore well potentially can cost millions of dollars a day to unplug, and it also costs a lot of money to prevent the plugs from occurring again. There's a number of mitigation strategies that are used in the oil and gas industry, which require that they pump millions of gallons of organic fluids, things like methanol, down into the well to mitigate these substances from adhering to the surface of the pipe. So the coating basically takes the place of these other solvent-based mitigation strategies, which they present a big environmental impact, potential impact on the environment if you have leakage of those solvents.
Take us to the offshore drilling site for a moment, because we think of them as, out there in the middle of the ocean, separate from our lives. But really, what's going on out there does impact our day-to-day lives. Can you kind of connect those dots for us?
Sure, yes. Any additional costs that it takes to recover product, meaning oil product, that will be processed later, let's say, into a fuel like gasoline or diesel, any added cost to that eventually affects the consumer.
That was the last episode recorded in our studio in 2020. With a new coronavirus emerging and a global pandemic looming, we turned to SWRI scientist Dr. Jonathan Bowman, who was working to identify drug compounds that could fight the virus. Bowman was collaborating with Dr. Ricardo Carrion and his team from San Antonio-based R&D organization Texas Biomedical Research Institute. Both researchers joined us to discuss COVID-19 in April. To close out, I do have a question for both of you. I'll start with Jonathan. Jonathan, as a scientist on the inside of this fight, you have a unique perspective. Any words of advice, encouragement for our listeners? We are just overwhelmed by the news we are hearing every day. Our lives have completely changed almost overnight. Is there a light at the end of this tunnel?
I would only say I've never seen scientists working harder and faster to solve a problem in my career. That's a reassurance there, and working together.
And I think that definitely gives us all hope. And Ricardo, same question for you. Any words of advice or encouragement for our listeners in this unprecedented time?
I think there is hope. So, as Jonathan mentioned, working together, scientists are coming up with ways to help defeat the virus, preventing it or helping those that are sick get better. And I think the other thing is that we all have a role to play. So it's very important to stay home. Not to go out when you're sick, to isolate yourself when you do become sick, even if it's not coronavirus. It's only by doing this do we buy time, and also help minimize the impact to those that can be really severely affected by the disease.
By May, wearing masks to leave the house became the norm, and frontline healthcare workers were finding innovative ways to overcome mask and PPE shortages. SWRI engineer Dr. Imad Khalek and his team changed course from testing engine emissions to testing mask materials for safety. Tell me about your work with engine emissions and how that carried over to testing mask materials.
Yes. So in my focus in engine emissions is on sub 1 micrometer particles that are emitted to the atmosphere. And those go all the way down to nanoparticles as small as 10 nanometer. So even in the engine emission arena, we cover particle emissions in the size range between 10 nanometer and 1,000 nanometer. We have lots of experience in this area in terms of particle mass emissions, and recently there has been particle number emissions based on the number of particles that are inhaled by individuals. These particles are small. They can actually penetrate deep to the lung, and research show that they can enter the bloodstream and can be found in various organs within the body. What's interesting is when you look at an internal combustion engine emission particles, their size or their mean diameter can be on the order of 70 nanometer to 100 nanometer, and that actually can move either down or slightly up. And what's interesting is the COVID-19 virus has a size range that is very similar to combustion sources particles in the 70 nanometer to 120 nanometer size range. So that's actually this is one of the things that we can apply in particle emissions from combustion sources to viruses and to a certain degree bacteria that have similar size range to that of particles emitted from combustion sources.
Mask testing was a first for the lab, but they had the right knowledge and experience to get the job done. Rolling through our podcasting year, in June, we highlighted a new, cleaner diesel engine. SWRI engineer Chris Sharp told us why the technology is a win for human health. What is the big picture potential of this technology? When we say near zero emissions and lowering the emissions, coming out of these big trucks, what does that mean for all of us?
Well, what it really means for all of us at the end of the day is cleaner air. It means that, we can, with these kinds of technologies, what we can ultimately do is we're effectively looking at eliminating the impact of transportation on public health in a big way, right? And that's a huge thing. I happen to have a daughter that suffers from asthma herself. I remember her going to a soccer tournament in Southern California and coming home and having to do a week's worth of breathing treatments because her lungs were irritated. So I have a very personal experience with this kind of thing now. And there's a lot of people in the country that still live in areas that have compromised air quality. And we've made huge strides since the kind of the miserable smog of the 1970s, but the air is not healthy yet. And people who are compromised, older people, children, people that have asthma, still suffer a lot of health effects and a lot of difficulty because the air is not as clean as it could be. And transportation is a big part of that right now. If, when we get technologies like this onto, all the vehicles that are running around out there, then, if you're really at zero or that near zero, then you really are eliminating that problem. And that's a huge improvement in quality of life for a massive number of people.
Great job, Chris and team, for developing a technology with the potential to benefit human health. In July, we stayed on the emissions topic and spoke to SWRI Principal Engineer Dr. Graham Conway. We discussed electric vehicle emissions, a conversation based on his eye-opening TEDx San Antonio talk. But if you took a wider approach and looked at the big picture, your information was that it actually is not as environmentally friendly, and it's not, zero emissions may not be accurate. Can you touch on that a little bit?
Yeah, absolutely. So I guess to go back a little bit, it would be the way we currently measure emissions in the automotive industry, especially for the cars that you and I would drive, is we hook up a emissions measurement device to the exhaust, and then we drive it over a prescribed distance at a certain speed, and then we measure the emissions that come out of that. And then that's what we use to say what the fuel economy numbers are and what the emissions are from that vehicle. Now, if you try and do that measurement technique on a battery electric vehicle, you're going to come up with an answer of zero because there is no tailpipe making those emissions. And that's where the moniker of zero emissions comes in, and everybody's fairly comfortable with that because, as I said, that is a true result when you try to measure it like that. But my point is that there is a lot more to it than just what's coming out of the tailpipe of the vehicle, and that's where we come to the box you were talking about, where I had an image of a vehicle sitting in the middle of the screen. It was an electric vehicle, and again, if you just put the measurement box around the vehicle, you don't get anything like CO2 and you don't get anything like NOx emissions. But that vehicle doesn't power itself by magic. It uses electricity, and then that means, you really have to look at where the electricity comes from and how the electricity is generated. And if you do that, you draw a box around a much bigger picture. And then you start to see that, in certain places, our energy isn't quite that clean. So we burn coal in power stations to make electricity, and that puts out a lot of emissions.
Interesting perspective. SWRI researchers are always finding new ways to understand complex challenges. Continuing through 2020, in August, we learned about the supercritical transformational electric power pilot plant at SWRI, built to demonstrate supercritical carbon dioxide technology, which promises lower cost, lower emissions electricity. SWRI engineer Dr. Aaron Mccullough explained how it could be used. Are you talking about use in power plants, homes, businesses? When you say commercial, what is kind of the end? What's the vision that you have for it?
So the vision that's been progressing is utility scale. So the end application would be a provider such as CPS operating a plant using carbon dioxide technology at the utility scale to provide power to their customers. So that's one vision. Another application is you have a steel mill or a cement plant or an industrial process that generates a lot of heat. It also has heat as a byproduct. A new market is CO2 for waste heat recovery, where you can actually work with a industrial provider to convert some of that waste heat back to power. So that's an additional benefit, less emissions. That's an entirely new market. You can do the same thing for the pipeline industry. So right now, the big focus is on utility scale. But once you demonstrate the technology, once you kind of have initial buy-in, you also have new markets for waste heat recovery. We're also working projects unrelated to STEP, but using the same fundamental technology to apply it at the kilowatt scale. And if you can apply it at the kilowatt scale, that opens it up for cars or heavy-duty trucks or actually home applications. So the fun thing about CO2 technology is it's a very broad spectrum of where you can actually apply it.
So we could one day potentially see SCO2 power just about everywhere. From a new form of power to new insight from an asteroid. In September, Dr. Vicki Hamilton, an SWRI staff scientist and co-investigator for NASA's OSIRIS-REx mission, spoke to us about exploring the asteroid Bennu and what we could learn from it. What impact could this have on humankind? I mean, as you mentioned, there are a lot of firsts here, and this is a really big deal.
Yeah, so I think there's a few different ways this mission will impact humankind. So I think, the first answer needs to be about what does the average person on the street care about? And so the thing that is probably most relevant to the daily lives of people is what we can learn about the hazards that asteroids in Earth-crossing orbits pose to us. So there've been instances in the news even just a week or two ago from when we're talking about small asteroids that whiz by the Earth, and how we don't even know some of them are there until very shortly before they fly by or they actually impact. And even if they burn up in the atmosphere, someday one might not. And there was an impact called Chelyabinsk in Russia a few years ago now that, was really quite dramatic and nobody was expecting it. And if a particularly large asteroid hit the Earth, that could be very, very damaging. So the data that we're collecting at Bennu help us understand how the orbits of asteroids change over time, because they do. They're not the same. And so part of the uncertainty in whether we're going to get hit by any given asteroid is just not knowing if its orbit is going to stay the same and continue to pose a hazard to us. So we're trying to help educate the science community with our data about how we can better predict which asteroids may become hazardous or less hazardous over time. So that's one thing.
And Vicki told us a sample of the asteroid surface could also shed light on the chemistry of the early solar system and the origins of life on our planet. The year of working from home, online shopping, and Zoom meetings brought about an important conversation on cybersecurity. SWRI manager and certified information systems security professional Victor Murray gave us some valuable safety tips. So what is your advice to stay safe online? I think you've kind of touched on it with maybe we don't put as much information about ourselves. That would be a great place to start, but kind of walk us through your steps for online safety.
For sure. And I mean, if you're publishing online, I'm not saying that's bad. But in general, for staying safe, there's a large number of things to do, but use passwords. I mean, if you have a portable device, make sure you're locking your device. If you are logging onto websites, try not to reuse the same password for everything. There are hacks that expose usernames and passwords for big name websites. And if you use the same password and username on all of your websites, and somebody gets in your username and password gets published, people will go and try them on other, if some website gets hacked, they're going to go to Amazon and try the same username and password. And if you use the same password, they're going to be able to get access to your account. Now, there are a lot of times, Depending on the company, there are sometimes secondary catches to, they'll send a text to your phone or something like that, which is a dual verification, two-factor authentication of that you are you, which can stop some of those attacks. But some of them do not. Let's see, encrypt your portable devices. You don't want, if you lose your phone, you lose your iPad or smart tablet, you don't want somebody to be able to get it and access the data that's on there. Phishing links. Be careful what you click on, from text messages, from emails. Clicking on a bad link can give somebody else full access to your computer or smart device or your networks at work.
Great advice. And there's more information available on episode 24, Cybersecurity Awareness. In November, we highlighted our winners of 2020 R&D 100 Awards presented by R&D World Magazine. SWRI engineer and director Paul Evans told us about a robot-guided laser for aircraft paint removal and discussed the evolving role of robotics. SWRI engineer Finley Hicks shared his insight on an advanced software system protecting fighter jet crews. What is the takeaway today? What would you like our listeners to remember about the laser coating removal robot or robotics in general?
So that's a great question. I think at the end of the day, I would encourage people to set sights beyond the here and now and beyond what robots do for us currently, and look towards the future of where robots can complement humans and the work that we have to do. And there's still a lot of work to do in putting robots into positions where we can employ them in highly repetitive jobs in dangerous areas where robots are just better suited. And then that frees us up to work on things where we can innovate. We can extend robots to new places where they've never been before. So that's what I would encourage people to think about, is what are the range of possibilities? If we can dream it, we will be able to do it.
And why is a test system like Sparta important?
Well, these jammer systems I'm talking about protect some of our military's most valuable assets and people. And the more capable or the more exact these systems are, the more effective they'll be at their purpose. It's the job of a test system like Sparta to ensure that jammers do exactly what they're supposed to do. Like I was talking about before, jammers they spoof enemy radar, they confuse them, they can do some really cool things. They can make an aircraft look like it's going faster than it actually is, or maybe going in a different direction. They can also make it look like there's hundreds of like an F-15 instead of just one. So as you can imagine, if they're really effective at doing that, then a radar operator won't have a clue where to shoot a missile. But if they're not effective and the radar operator can tell the difference, then that's disaster for our crew.
And that wraps up our podcasting year. You can hear all of our episodes and see photos and complete transcripts at podcast.swri.org. Thank you to all of our 2020 guests and to you, our listeners. Stay tuned for more listen and learn moments in 2021. Remember to share our podcast and subscribe on your favorite podcast platform. Want to see what else we're up to? Connect with Southwest Research Institute on Facebook, Instagram, Twitter, LinkedIn, and YouTube. Check out the Technology Today magazine at technologytoday.swri.org. And now is a great time to become an SWRI problem solver. Visit our career page at swri.jobs. Ian McKinney and Brian Ortiz are the podcast audio engineers and editors. I am producer and host Lisa Peña. Thanks for listening.